So today we're going to be on Chapter 4, Day 3. We're going to talk about fixed points and iterations. A fixed point is a point where, on your graph, where f of x equals x, meaning that the input is equal to your output. So that's what a fixed point is, the point where the x value is equal to the y value. So for number one, we're just going to go through some examples here. We're looking for, in the following examples, we want to find that fixed point, find a point on that graph where the input value matches the output value. So for number one, we're going to talk about two ways to do this. Algebraically, if we're looking for a point where the input is equal to the output, well, if my input is x and it's got to be equal to the output, which is f of x, the way that we do this algebraically is we just replace the output with an x. Because now the input that we're using on the right side is equivalent to that output on the left side. And whatever value we solve for x is going to be the input that causes this to happen. So we just go through it. We have 5x equals 5, divide by 5, divide by 5, and x equals 1. Now, one thing to note when you're using algebra to solve these, and this is really important, so let's go ahead and make a little note up here. Just keep in mind that extraneous solutions are possible when, let's put possible, because it's not guaranteed, but they're possible when you multiply both sides by a variable or you square both sides. So if you remember back in Algebra 1 and Algebra 2, there were possibilities when we were solving algebraically where if we did multiply both sides by a variable to cancel out a variable, or we squared both sides, it was possible that we came up with an extraneous solution, which means it did not work. Well, if we look at our example here, we did not multiply by a variable at any point, and we did not square both sides, so we're good. If you want to double check, you can just plug it in. If we did plug it in, that would mean 1. If I did want to check, I just plug it in. 1 would equal -4 times 1 plus 5. And then if you just go through that, it does work. Okay. But it is important that if you do one of those two things for when the extraneous might be possible, that we do check. Now, graphically, the other way we can look for these fixed points is graphically. On your calculator, you're just going to plug in for y1, you're going to plug in the function. So we're going to plug in -4x plus 5. And then for the y2, we're just going to plug in x. And then what you want to do here is you want to find that intersection point. So once you graph on your calculator, we want to graph both of those as y1 and y2. And then you're going to hit second calculate, which is the trace or the calculate button, and then scroll down to intersect. And then after that intersection, you're going to hit enter on both lines, and then enter a third time. And it should give you that intersection point of 1, 1, where your x value matches your y value, and that's your intersection point. Okay. For all the ones today on the notes sheet and most of the homework, you will be doing the algebraic approach. But if you did want to find it graphically to double check your work, you can do that. Moving on to number 2. Again, all we're doing today for this front half is we're finding the fixed points, which means that our input, which is x, has to match our output, which is f of x. So you just write those in, and then we're solving. If we move that over, 0.3x equals 4.3, divide by 0.3, and then you get 43 over 3. We do want exact answers if possible, or 14.3 repeating. Now again, we circled this already because if I did check, looking back at when extraneous solutions are possible, we did not multiply by a variable on both sides, and we did not square both sides. We don't need to check, but if you did, it would work. Now, keep in mind, it only works if you are using an exact answer, because if we did 14.3 and we stopped there, then it wouldn't work on both sides. But because we use the exact answer, it would work. So now that we have the idea of what a fixed point is, go ahead and try number 3 on your own. Pause the video, try it, and then unpause it and check your answer to make sure that you got it. All right, so looking at number 3, here's the work. Again, we're just finding a fixed point so that our output matches our input. One thing you got to do here is you got to distribute the right side, get 0 by itself, and then you're factoring out a GCF of x, and then each factor solves as 0 and 19/3. And again, we did not do either of those two things, so if we did plug them in and checked, they would both work. Moving on to number 4, going again through the same process. I know it seems like it's starting to get repetitive, but we'll notice there's a little bit of a difference on this problem. We make our output equal to the input, and now we're going to make a big star here, because the next step we have to do to solve for x is we have to multiply both sides by 2x plus 3, and we're making a star there because that means we are multiplying both sides by a variable. So because these cancel out and we multiplied both sides by some variable, we are going to need to check at the end for extraneous solutions. Go ahead and distribute that out. 2x squared plus 3x equals 4x plus 1, and then move everything to one side. 2x squared minus 1x minus 1 equals 0. And now if we go to factor this, we have 2x and x. We have a 1 and a 1. And we have a negative and a positive. Okay. When we go to solve for these, we get x is equal to negative 1/2 and x is equal to 1. Now again, we said because we multiplied both sides by that variable, we do need to check our answer at the end. So when we go to check it, let's go ahead and do this in green here. If I'm checking x equals negative 1/2, we have negative 1/2 equals 4 times negative 1/2 plus 1 over 2 times negative 1/2 plus 3. That would be negative 2 plus 1 is negative 1 over negative 1 plus 3 is 2. So we do have that this one works. And then if we have to check x equals 1, when we go ahead and plug it in, we have 1 equals 4 times 1 plus 1 over 2 times 1 plus 3. And we have 1 equals 1 equals 5 over 5, which does work. So in this case, they both do work. Okay. Just be careful as you're checking. Make sure you're very careful with the negatives and the fractions. You don't want to do all the work right and then accidentally not check it, and one of them is an extraneous solution, or check it but make a mistake and you accidentally cancel out one that is a real solution. All right, moving on to number 5. Go ahead and try this one on your own. Pause the video. Try it on your own. and then when you're done, pause it, and then check your work and see if you got it right. All right, so looking at number 5, if we check out this work here, again, as always, looking for a fixed point, your input is going to match your output. In this case, though, we need to move the 7 over first, and then again, let's highlight this in red, we squared both sides to undo that radical. So because we did that, we know we have to check for extraneous solutions at the end. As we go through that, we notice once we get our x values as 5 and 10, when we checked the 5, it did not work. So 5 was an extraneous solution, 10 was not, so it did work. Okay? Again, be very careful and make sure that when you do one of those two things, squaring or multiplying by a variable, that you do check for extraneous solutions at the end. Moving on to number 6, another one. Go ahead and try this one on your own, giving you guys a lot of practice today. Again, just the concept of a fixed point being the input matching the output. Algebraically, you guys, all you're doing is replacing the y value of the function h of x with the x value, the input, and then solving for x, which you guys had done in Algebra 2, and making sure you're checking when necessary. So go ahead and try number 6, and then unpause the video and check your answer. All right, so for number 6, let's check the work again, replacing h of x with x. Move everything to one side. We did not multiply or square by a variable, so we don't need to check for extraneous solution, and this one's nice where it does factor, and you get some nice solid answers. The last one on this front page here looks very similar to number 4, so we're going to go ahead and follow kind of the same protocols here. Input matches the output. As we said, we have to multiply by x minus 2. So the second we do that, we're going to have to make sure we check for extraneous solutions at the end. These cancel, distribute it out, and then again move everything to one side. So just kind of going through these same steps as we did on number 4, we have the setup the same as we did before. But what we do notice here is that in this case, this is not factorable. Well, since we're in honors pre-calc now, we do have the tools and the knowledge to be able to finish this problem still. So we have to use the quadratic formula. When doing this, we have the quadratic formula is negative b, so negative of a negative 3, so just put positive 3, plus or minus the square root of b squared, negative 3 squared minus 4ac all over 2a. And when we go through this, it's 3 plus or minus, that'd be 9 plus 4 is 13, all over 2. So we have our two solutions. When you go ahead and do this, remember at the very, very end, we already said it, because we multiplied by a variable, I would highly recommend that you just type it into the original in your calculator. So we're going to check it in your calculator. Okay, so again, you would just find the approximation of 3 plus square root of 13 over 2 by typing that in your calculator. And then you need to plug that exact value in for both x's and make sure that the output would be the same value of 3 plus root 13 over 2. Okay, and then when you do that, you're going to notice it does work. You get the same output, and then you're going to also have to plug in 3 minus root 13 over 2, and you'll notice that again, your output does match that input value. So therefore, those are the two fixed points, and that is how you find a fixed point on a function. Moving to the next page, we'll talk about iterations here. The concept of iteration is pretty simple, actually. You have a function, and what they'll give you here is x naught which is called your seed value, meaning it's your first input. Okay? So if I want to find the first iteration, the way that I find that is I plug x0 into my function for x. Okay? So when I do that, we end up getting negative 0.6 times 0.05 plus 1. That gives me an output of 0.97. Okay? After that, I'm at my first iteration. What I want to do to get to my second iteration is I take my output from the first one, and that becomes the input for the same function to get my second iteration. So we're going to plug in negative 0.6 times 0.97 plus 1. So we're using the same function, but now my first output becomes my second input. And when we do that, the second iteration becomes 0.418. And then how do we find the third iteration? Well, you guessed it. Take the second output. That becomes your third input. Now you can already see here how this would become kind of tedious. It's already asking us to go to the 14th iteration. And I don't want to be plugging the same stuff in. So we're going to go ahead and show you how to do this on the calculator. Now, if you're finding iterations, I would highly recommend, if possible, if in the homework it says you're allowed to use a calculator, using your calculator to find the iterations. It makes it a lot easier. So if we look at the example on the back page that we were just talking about, we got to go ahead and plug in the seed value. So I'm going to show you how to store values if you don't already know. So I want to plug in 0.05 as my, I'm going to store it. So STO arrow. I'm going to store that as my X value, and then I'm going to hit enter. So now anytime I hit X, that value is going to represent 0.05. Okay? Well, we have our function that I want to plug it in for. So I want to plug in negative 0.6x, which we said was 0.05, plus 1. Oh, I'm sorry, plus 1. But because we're doing iterations, I want that output to be stored. So I hit stored. That output, which we just said was negative 0.6 times 0.05 plus 1, that output is going to be stored as my new X value. Okay, so if you get it to look like this, when I hit enter, this is going to give me the first output, or the first iteration, which we said was 0.97. Now the reason the calculator is so nice with this is because if I just hit enter again, it restored this X value of 0.97. That's going to be my new input for the same function. That gives us a second iteration that we talked about. And then we can just keep hitting enter. And now I can find the fourth iteration, the fifth iteration, and so on. Okay, so I'm going to go ahead and continue this on and transfer it to the paper. And then we're going to kind of talk about what this means. So as we go through the further iterations on this list, you're going to notice we start approaching, in this case, some number of 0.624 or 0.625, right? So this ends up being closer to 0.624 or 0.625, right? Well, if I keep hitting enter and I keep going down, the 46th iteration would be 0.625. And then once I hit enter again, the 47th iteration would be also 0.625. Well, what does this mean? If I hit enter again and I do the 48th iteration, that means that my input would match the output, right? So the input for the 47th iteration matches the output for the 47th iteration, right? Well, what do we say that meant on the front side? That means that this is our fixed point. So this is why we talk about iterations, because in cases where there is a fixed point, we already saw There are possibilities where there's an extraneous solution or there's not a fixed point at all. That's not possible, but we can use the iterations in many cases to find those fixed points. Okay, so that's all iterations is using the previous input to find the new output and then continuing that pattern. And in cases where there is a fixed point, the iterations can help lead you to that fixed point. All right? So go ahead and try the homework for tonight, and good luck.